And today I will talk about financial operations. I wanted to do a brief introduction on the context of this work, which is a mix of a future product and a research work. So it's an architecture, a framework, an idea, a proof of concept. It's a research. So the context is, if you followed this morning presentation by Steven on Crossplane, is that's exactly the context, which is to use Kubernetes as a tool to deploy applications and manage other software. This is the idea that this work is based on. So, and also, there's been another talk also this morning that introduced the problem of managing cloud solutions, and that talk ties in perfectly with mine, which is exactly on that, because cloud computing and all its tools, all the software and services that are available, it's a great way to do great things and introduce, have redundancy and all the benefits. And you don't need to invest into someone to have a local cluster. You don't need to invest into knowledgeable people that know how to manage such a complex infrastructure. So this allows for us this layer of simplicity that can bring with it the pitfall of costs, because now you don't have someone that is an expert on managing these systems, and it can happen that there are hidden costs, or for example, communication costs between for example, microarchitecture. You may have communication costs where there are 1,000 microservices that are all communicating together and they are generating massive costs. So we have this problem. We need to gather costs. So we need to analyze these costs to know where they are coming from. Cloud providers such as AWS, GCP, or Azure all have their internal tools. They allow to have quite an overview of where we are spending money. But this overview is, of course, dedicated to this service. To each service has its own costs. And if you want to have a more general overview where perhaps your company has a multi-cloud infrastructure or is relying on multiple services, it's not just about infrastructure. There might be costs for licensing applications or other costs like that. This means that we need to either create a solution, a specific solution that our company needs to code itself. And this also brings forth the challenge of standardization, because all these different services will have different formats for cost reporting. So since they may have different costs, different metrics, they may have a different format, even like the format of the file itself may be a challenge in itself, because they are all different. So this means that we need to connect to these different APIs to download this data, analyze it, and they might be all different. And then we code our solution to integrate all these different services, and then one of these APIs gets updated. well, usually they maintain the older versions as well, but maybe we have there is a new feature that we might want because it might bring useful insight. So we have to update our in-house solution. And this might bring additional costs because someone now has to go and look at the new API, develop a new solution, and then deploy it, which might bring downtime and so on and so forth. So going back to the financial operations, this is let's say, a new approach where it tries to include accountability into what everyone is doing. So we are not simply going to activate a new service because we need it. It's a practice where we want to improve how everyone uses resources. And along this cultural shift, let's call it a cultural shift, it also brings tools. Oops. It also brings tools, and because to help with this challenge. The idea is that we want to be able to quickly add new services to analyze new costs without having to redeploy everything, without having to consider each service as its own service and code a specific solution for that specific service. So the main problem is that we have to create this standardization layer. One of the tools that the FinOps Foundation, actually, which was mentioned earlier as well, is that the FinOps Foundation is working on this tool, and it is the FOCUS specification. Well, it's a redundant specification, but the FinOps cost and usage specification. And this specification it standardizes billing and utilization. So it includes information not only about how much did you spend, how much was the bill, but also which resource, which are informations that you will find in a normal cost and usage report. So if you go on AWS or Azure and download the cost and usage report, this is information that you will find there. However, this information in the FOCUS specification is standardized. And this allows to remove completely that standardization layer that we needed to perform our data analysis on different services. If you are wondering about the standard, a new standard, about the availability of a new standard, because there is the classical XKCD about there are 14 standards, so we have to standardize, and now there are 15 standards. It's the usual. However, this time it would look like, firstly, it's the first one. So there is a good chance that it might stick, maybe. And secondly, it's backed up by a lot of companies, and especially the main cloud providers. Google, Microsoft, Azure, Oracle, and others that you can see. So with this, what we envision is what we are building is a framework that has to perform and solve 4 main challenges. And the first one is a data collection problem. So we have many services. We assume we have many services, and we need to collect data from each of these services. Then we have this standardization, because while the future may become where everyone is using FOCUS, right now it's only available on Azure and Google. So there is still work to do. We can't go and use it, and perhaps some minor service providers may never use such a standard. And then we have a problem of analyzing this data. we need to store it, and we need to know which optimizations should we apply. Like, we have all this data coming in, what should we do with it? Because if we don't value this data properly, it's just going to be an additional cost, and we solve nothing. And finally, we need for this to be automatic. We don't want to have to code a specific solution for each application, for each service, because otherwise we are right back where we started. So now I'm going to show you our idea, our framework, where we want to perform data collection, data standardization, and data analysis in an automated way. And this is achieved, as I said, the context is similar to cross-plane. Actually, I showed this research project is in collaboration with Crateo Platform Ops, which is another project that does a similar thing. And we're working in that context, so assume that what you're going to see is using Kubernetes as a tool and not necessarily to run containers. So this is the architecture. I'm going to spend a few moments to explain it because it's a mess. So starting from the top, we have what is going to be the part that the user interacts with. Right now it's custom resource definitions, and there are going to be custom resources created by the user. In the future, perhaps it's going to be a UI, it's going to be whatever. And these are the only part that the user should ever interact with. And there is two kinds that we envision. So the first one is simply a API endpoint, how to access it, how is the data coming from, made, what is its format, and hopefully this endpoint is going to be FOCUS. It's just going to be in FOCUS. We just read it. We know how it's made. The only problem is parsing the data, be it JSON, CSV, YAML, whichever. Then these custom resource definitions are controlled by operators. And these operators start a series of exporters. The exporters use a standardized format, which is Prometheus, and they take the data and they expose it in the standardized format. Then this data is scraped and stored into a database for analysis. In our case, it's a data lake. The second custom resource definition that we created is dedicated to other kinds of costs, those that are not exposed by an API endpoint. So for example, like a really dumb example, what happens if you call the technician because one of the computers broke? There is no API for that, but that is a cost that a company still has to sustain, and it needs to go in some budget somewhere. And that could become helpful in the future for forecasting budget. But I did say, however, that the focus is not going to be the be-all, end-all, or it might not be. So this is why, and it isn't right now. So this is why you can see there is a data standardization service. No one has mentioned it yet, but I didn't think it would be me at the end of the day, but we wanted to integrate large language models because what if we want to convert this data, the schema of a random API endpoint into FOCUS? How can we do that? Using an algorithm would probably not work. So how can LLMs do so? And next episode I'll tell you. First, let's look at data collection. So We implemented it through operators, CRDs, custom resources, definitions, custom resources. And the user simply has to create the custom resource, and the operator will create a generic exporter that takes all the information it needs from the custom resource. And this is ideally a generic exporter, which means that for the majority of services, it needs to be the same one. We just configure it every time. We configure it with what is the endpoint, what kind of authentication do we need, what parameters, and so on and so forth. Then we also initialize the scraper, which is going to need the information such as polling rate, and these are all configurable. Here is an example of what we are using right now. This is absolutely temporary. For now, this works. This has been tested on Azure, and it works. And there are two main parts, which are the exporter configuration and the scraper configuration. And we can have the URL, we can include parameters, and all this stuff. And there is also the database configuration, which I'm not showing here because it's also another set of URLs, username, password, and stuff like that. I'm not going to show you the other custom resource, which is the one for Focus, because it's simply, firstly, it doesn't exist because we haven't made it yet, but and secondly, it's just going to be the fields. The fields of the Focus specification, so date, build costs, resources, subscription types, and so on and so forth. So this is the custom resource that starts the whole process. And as I mentioned before, if our company hires a contractor, we also want to get that data budgeted. This translates into manual cost input. And yes, this is not in the spirit of automation, automatic, everything is, but of course we cannot ask for some random contractor to, hey, can you please have an API endpoint where I can pull data? I mean, these are also managed by an operator, and they are taken and exported also in the Prometheus format, and the pipeline is exactly the same. It just changes that instead of having an API endpoint where we download data from, it's a custom resource that we transform. Now, I'm going to talk about the perhaps most interesting, but also hopefully less useful, because we hope that Focus will just take the place of this kind of requirements of data standardization. So, as I mentioned, converting a schema is a difficult task, which is why companies add someone to do this. If we had a multi-cloud, there was a person that had to go and convert the data from whichever format into their company's format. So if there is Focus, that's fine. You convert everything into Focus. If the new data is Focus, everything is good. But if we do not want to have someone do it, because perhaps there are many services, or there are new services that are coming out, or whichever reason, we wanted to test if large language models can have a satisfactory result. So we created a conversion algorithm that, given a cost report, analyzes its schema and tries to convert it using large language models. We created this web service that takes the two schemas, the two files that actually the schema definition of the Focus and the file that needs to be converted. And this service performs a procedural conversion at first. And then queries a large language model for all those fields that it cannot convert. How exactly? Here you go. So it's three main steps. The procedural conversion is a basic algorithm. It can be summarized in it checks the Jaro-Winkler distance, which checks if two words are similar. And if this distance is greater, that means that they are the same word now. If it's 0 point, and that's our result, it's the same word, we assume it's the same column. If this distance is 0.9 or greater, that means that the two words are extremely similar. But since it's not the same, we have to look at all the words that are extremely similar. So we take the most similar. We could also think about taking the most similar and querying the large language model, but that choice is, this also works pretty well. If we don't find similarities, that's when we want to ask the LLM, how would you map this field? And the way we do it is by querying it and giving it the list of fields, the specification, the focus, the sample data, and the possible list of fields that this could be converted into. And we did so in 3 main ways. The first one is basically taking a CSV, the specification, and asking how would you convert field A into the focus specification. And we did so for each field. The second type is instead we give one field at a time with the list of target fields that we want to convert it into, and or like a set of possibilities that we can convert into, and given it sample data. The third one instead also includes the telling the LLM what it is, so it's a conversion agent, giving sample data for each field, and the actual description from the focus specification document of what the field is. Then we run it through 4 large language models, which are Llama, ChatGPT-3, ChatGPT-4, and Mistral. And you can see there the various models. And of course, we use the same seed. We configured the temperature to be low, and the top percentage to improve our results. And this was in an attempt to get somewhat deterministic results across different runs. And then we tested the cost reports from Azure, AWS, and Oracle. Because these are the ones that are already supporting the focus specification, we could have, without guessing, we could have the correct mapping. And here is the table of the results. And, well, it's a bit complicated. Well, not complicated. Well, anyway, the point is that, well, GPT-4 was the best, if anyone had any doubts. And also the third type of query was the best. So giving a complex query with lots of data, but not too much data. Giving the whole CSV turned out to be the worst possible solution in basically all cases. So there is not only the problem of creating the infamous prompt engineering, but there is also the matter of giving the right data. Then when we have converted all this data, we have our exporter that is giving us this, let's say, twofold standardization. Firstly, in the Prometheus specification, and then in the focus, in the Prometheus format, and in the focus specification. We need to scrape it and store it. So we have this set of generic scrapers. Now we have in the Prometheus format. We know exactly how that data is made. So we can just have an absolutely generic scraper and read the data and put it in a database. Then again, we know exactly what the schema of the data is, so we know how the tables are made. But even though we have all this data, all this cost data, this is not enough. Let's assume a simple example. We have this web server that is running an application where some users connect and does its things. If we ask an algorithm or to optimize this cost, what is going to happen? We only have the cost and we want the cost to be zero. What is the solution? Just turn off the virtual machine, turn it off, which is, I mean, not exactly the best. So we need additional information. We need to know which resource caused the cost, and then we need to look at that resource, what it is, and look at its metrics, for example, CPU usage, and also have the key performance metrics. So, for example, in a web server, if there is a page that needs to, or a service where someone needs to make a request and have an answer, we are going to need some key performance metrics. So for example, it needs to take less than 500 milliseconds. On average, it takes 300. Okay, great. There is room to decrease the capacity of the virtual machine to get closer to that 500. We decrease, we make the service worse technically, but if our performance target is 500, then it should be fine. And we're also saving because now the virtual machine is simpler and it costs less. So to do so, we just look at the focus table, and in the focus specification and also in the custom reports from Azure, AWS, etc., well, there is the which resource caused the cost. So we just go and look at those resources and perform a sort of API scraping and exploration, and I mean, there is no time to explore that too. So another interesting aspect of using large language models is also querying for data, for data analysis, is also querying large language models. Of course, we could use statistical analysis, pattern recognition, and all these algorithms that are already famous. But there is this new approach which is based on, for example, if you go on OpenAI, you can use the code interpreter tool, which allows to upload a file and then, for example, ask for analysis. This is a new way where if you have large amounts of data, it can bring insight, for example, by asking what would happen if. So, for example, what would happen if we switch to a different provider, maybe one day? And so that's one way, and connecting to what I said was the context. We can then, from the database, we can then feed all these metrics that we computed. We can feed it into Kubernetes, into the autoscalers. But that's minimalistic, let's say. Or we can use a tool such as Crateo or others to have operators look at this data and then perform actions directly on the cloud. For example, having an Azure operator, an AWS operator, where the analysis tells us this virtual machine could be smaller, and then feeds this data back to Kubernetes and modifies the custom resource for the deployment of the virtual machine on AWS, automatically optimizing the costs. I have a quick video. It's 1.5 minutes, then I'm done. Okay, and this hopefully doesn't go too fast, but here I created the custom resource. You could see the exporter and scraper appear, and this is the large language model conversion. So this is sped up, it's not this fast. And on the left, you can see the request map, the name of the field, and the list of fields that are being considered. Of course, this is not the full query. The full query is more complex, it's much longer. Then we can see that now the scraper this data is now being exported, and this scraper is uploading the data into, in this case, we used a Delta Lake, which is Databricks on Azure. And you can see the job running to perform the upload into a table. and this is also sped up, and it's gonna finish. And well, I'm gonna just show the select all from the table, and so. And you can see these are the columns for the focus specification, this cost, and etc. So, in conclusions, should be this is an approach for cost collection for cloud-based services, but not only cloud-based services. As we said, the contractor is also a valid source. It's an automated framework to standardize, to collect, standardize, analyze data. And it's also a new approach for data standardization and moving towards this focus specification. The idea is to try and use LLMs for more. For example, the data analysis is an important aspect that we want to include. And because it could be interesting for cost-related analysis. And that's it. Thank you. I hope it was interesting.
It was, in my opinion. Definitely interesting. Okay, raise your hand, people. Don't be shy, as usual. We have one.
Hi. Can you? Yes. I have just a curiosity about the introduction of LLM in operations. Did you consider the potential impact of hallucinations? And if yes, which are the steps you forecast to adopt to avoid them?
Yes, thank you for your question. That's actually a very interesting point that for time I didn't get to mention. And if I go back to the results here, as we can see, the averages that we can get from conversions are not incredibly high. If you look at the best scenarios, and we consider that we always get the best model for each, because it depends on the type of query, on the provider, and it depends. The average is about 85% across all models and the query type number 3. So if we consider 85% conversion, then we put this data into a database, and then we analyze this data, and we introduce additional inaccuracies due to perhaps imperfections in the algorithms or using LLMs again. This is not a good result. Because if our company has to rely on a system that is less than 85% accurate, this means that this is cost optimization. Like, we are asking this system to perform optimizations. However, we also need to consider that large language models are something that is exploding right now. And this 85% might seem low now, but if we think about how quickly they are evolving and improving, basically this is the worst it's ever going to be. So this means that in the future there might be no need to fix hallucinations, because perhaps it will get good enough where it's not 85 anymore, it's 99, hopefully. So this is the idea. So for now, just to shorten it, it's basically this is basically a proof of concept. So there is no actual intention of deploying it to any real architecture, because the problem of hallucination is very real.
Okay. Any other? While we are waiting for the next speaker, still have a bit of time.
Thanks. Hello. Thanks for the talk. It's really interesting. I have a question. It's not technical, nothing to do with. So if you have it your way and cloud providers and APIs support the focus specification, does that not mean that they will inevitably make less money? Because, if I have an over-provisioned VM or Kubernetes node, and then your system shows me that, they're going to make less money because I'll provision a smaller thing, right? So the question is, how do you get people to, how do you onboard them? What's their incentive for whatever cloud provider that doesn't support it yet? What would make them want to be a part of this financially? I know it's right, but you know what I mean.
Yes, of course. Thank you for the question. So, I would like to point out that Focus is not something we propose. It's from the FinOps Foundation. So it's a massive challenge to standardize all this company. And personally, I believe that this effort comes from, this standardization effort comes from the fact that it's a jungle. It's basically a jungle, and there is from companies that use these services, they want to have more accountability for these services. And the fact that so many, if we go back to the list of companies, so many are already part of it, and this is new. Like the Focus specification, even if you go back to 3 months ago, didn't exist. So it's, well, it did exist, but it was like a alpha release, which was a preview, and it's still a preview actually, but now it's more a release. It's a release candidate. So I think it's in the interest of the cloud providers to contribute to this project, mostly out of fear of being left out. Because if they are not the only one to have this easier accountability, that they might be left out because, oh, Azure has it, AWS doesn't, so it's easier on Azure. So that's my take.
Okay, time is running as fast as, I don't know, how big applause.
Thank you.
Thank you again.